Hello, welcome to this session, Turn It Up to 11, improving the performance of your Apex code. Really excited to be talking to you about this today. Quick introduction from me. My name is Paul Battisson. I'm the COO at Cloud Galacticos. We're a UK-based Salesforce consulting partner. I'm a 7-time Salesforce MVP. Got about 15 Salesforce certs at the last time I counted, and also the founder and co-leader of the Leeds developer group further north. I've written a couple of books on Apex as well, so learning Salesforce development with Apex for admins and junior developers, and mastering Salesforce, or mastering Apex programming, sorry, for more senior developers. And yeah, I'm here today to talk to you about Apex performance, how to improve it, and how to make sure that your code runs fast and scales nicely. So this is something that I've covered a little bit in one of the books, but I'm really hoping to dive into some things here to give you some top tips on how you can make things faster. So today's session is going to be split roughly into 4 areas. The first thing we're going to be focusing on is the question of what do we mean by performance? When we start talking about measuring something, improving something, and working with something, should really know what that something is. So we're going to take a bit of a starting look at what we mean by performance, the different types of performance we might want to measure and improve. And then we're going to look at how we do that. How do we measure performance? How do we go in, check what we've got going on in the background, measure it, record it, and view it? And then we're going to look at some code choices and the impact they will have on the performance of our solution, before finally wrapping up with some architectural considerations and the impact they have. So hopefully this will be a full kind of cover off of performance at a high level. We've only got 40 minutes, so we're not going to be able to go into everything in detail. But my hope is by the end of this, you'll be able to go back, look at your solutions, just think about how you can try and improve them a little bit to make them either faster, or just at least be aware of how you need to start interrogating them to see how you can improve them. So let's start by looking at what we mean by performance. So when we say performance, excuse me, we actually have 3 different things we can mean, or I bucket them into 3 different types of performance at least. The first is background and code performance. So that's how good is our code at doing what it's meant to do. And this can be either measured in things like just milliseconds and how quick it is. It could be how performant it is in terms of being able to be updated by a developer. And if it's asynchronous, it can just be how fast it's going, how many records it can process, and just how it's using the governor resources, which we'll talk about in a minute. The second type, which is what most people think about, is user perceived performance. And that's how fast the application feels to the end user. Now, this is probably the most important type of performance, and is the one we're going to be really talking about today. But it's only one facet of building out a performant Salesforce application, or any application really. The final one is scaling performance. Now, scaling performance we'll dive into in a minute, but scaling performance is really all about how we grow out the application. So obviously we start off with a small number of users, small set of functionality, and slowly build up and have more records and more things go on. So it's how does our system grow and scale as we do that? So let's start off by thinking about the standard Salesforce request lifecycle. And so everything on Salesforce pretty much follows this pattern. There'll be some slight differences and nuances, but most interactions will follow this image here. Starts off in box number 1 with the user looking at a web page. It might be Lightning Web Components, it might be just standard Lightning experience. Obviously, there will still be a few users that are looking at Classic, could be the web app, could be whatever, but they are looking at some view of the data. In box number 2, what they do is they'll go and make an edit. That could be creating a record, it could be editing a record, deleting a record, whatever it might be, but they'll make some change in the data that they want to ensure persists against the database. And so they will send that over in box number 3 across the internet up to the cloud in Salesforce. Okay, so there's some transfer of data. There's then some background processing that goes on here in box number 4. So something happens with that data to make a decision about what needs to be done. Are we creating a record? Are we updating a record? In which case it might be retrieving the record and populating the new field values. It could be we have some logic that's running, like a trigger or a process builder, something like that. And then in box number 5, we actually make a save and commit against the database, make sure we have the latest values. And then in box number 6, send that update back over the wire down to the user and update the page for them. So all of our requests pretty much follow this life cycle. Someone interacts with a web page, something happens on the server, and some update happens on the front end. Of course, we might have more client-side applications where things change on the front end first and then might bundle up a request to the server, but it still happens and follows this pattern pretty much, just with 1 and 2 changing a little bit. You'll see in boxes 3, 4, 5, and 6, there's a little sand timer icon, okay? And everywhere I put that indicates a spot where there is some delay, okay? Now, typically when a user is interacting with the web page themselves, there's no real delay, it's happening real time for them. But when they send that data across the wire, there's a delay due to network performance, bandwidth, they could be on a mobile, on 3G, whatever it is, there's some slowdown. There's then some time taken to process things in the background in box 4, some time taken to actually commit and make the update against the database in box 5, and then finally, some time taken to return the response in box 6. Now, all of these can happen really quickly, so it's slightly imperceptible. However, anytime we increase one of these, it increases the view for our user that, increases how long the user views this taking, okay? So if all of these take half a second each for every little egg timer, that is 2 seconds worth that the user is perceiving. And that's what we need to be aware of, is what the user perceives the time to be. And that should probably be the focus of where we're going to look at in most instances. So that covers off how we deal with user perceived performance and some of the background performance, because we want to make sure our code is quick to keep that up to date. But what about scaling performance and keeping that going? So by scaling performance, we want to check how our application performs as we add more users. So as more people are making changes to the system, they're probably going to create more records, okay? As we have more records, what does that mean? How quick are things to load? How big a set of updates do we have to deal with? How many records are being updated at once? We probably have more functionality as well. As people realize what they like and dislike about the system, they'll ask for new things. They'll have additional and extra things they want to do. We need to also think about how our triggers scale. Can they handle 1 record, 10 records, 200 records, which is what we need to be able to handle? How does our utilization scale as our use of resources scales? Same with processes and flows. Can they handle multiple records at once? What's the implication of them having multiple records at once? And so in general, how does our application scale and grow as we start doing more with it, with more people? And the reason everyone buys Salesforce is to get success. Okay, we wouldn't be buying the system unless it made us either earn a bit more money if it's Sales Cloud, reach some more customers if it's Marketing Cloud, help people if it's Service Cloud, interact with people via Community Cloud. We want success by having more of those things occur, and so we need to deal with this scaling. The other one is queries. As we're making more and more data within the system and searching against a bigger set of data in the database, how is that going to scale? What happens if we retrieve more data? How does our system handle that? And then finally, sharing rules. We want to make sure that our sharing rules scale. We don't need to have everything public read-write and have 100,000 records and everyone be able to see it. How does our sharing architecture impact the way in which our application is able to scale, particularly when it comes to things like reports, dashboards, and just general day-to-day queries and searching? So now that we understand a little bit about what we mean by performance, let's talk about how we can actually measure it. So when I start to work in improving the performance of an application, I like to use the OODA methodology. OODA is a methodology that came out of the US military and stands for Observe, Orient, Decide, and Act. And it's just a continual loop. And it's one that I quite like working with because it makes it very easy for me to work out what I'm doing and why, understand what's happening within the system, but also present it back to a business user in a way that means something to them. So what we do is we start off by observing what our system is doing. How is it scaling? How is it performing? How is it using resources? What numbers do we get? We gather some hard data. We then orient around that data. Why is this happening? What's causing this to happen? What does this mean for us? We then make a decision as to whether we need to make a change or not. If we're using, for example, 98 of our 100 queries, that we get, and we're worried about the 101 query exception, we need to make a decision. Do we go in and try and refactor some of our code to use less queries, or do we work with what we've got and just have it on our backlog? It's worth noting here that deciding to do nothing at all is a decision, okay? And that's a fine decision. We just need to log why we've made that decision. Not every problem needs to be solved straight away. And then finally, in step 4, we act. We make the change that we've decided to do, or don't make the change if we've decided not to. And then leads us back into our observation. Did that change make the improvement that we expected it to? If so, great. How can we improve things now? And what does the system now look like? If not, why not? How can we then go and improve it? If we haven't made any change, okay, let's just keep on observing the system and make sure that we aren't going to exceed a limit or break things. So the OODA loop and the OODA methodology works really well in helping us do this in a prescriptive and manageable manner. So how do we actually go about doing our measurement then? How do we measure our performance? So there are 3 key ways. First of all, we have the governor limits. The governor limits are going to ensure that we stay within them and that we are performant to an agreed level. So we have to be aware of the governors. We have the limits method. Salesforce within Apex provides a series of methods on the limit class that we will look at in a second and utilize to help us decide whether or not we're using resources appropriately. And then we can do some order analysis. And this is kind of where we'll be going a little bit off the beaten path here and talking about things that you might not normally do. So the Salesforce governor limits, I'm sure everyone has heard of, everyone's aware of, and everyone's familiar with. The governor limits provide a set of guide rails or guidelines for us when we're working with a system. It ensures that no single developer or no single actor on the platform is monopolizing the resources. I can't go and pay Salesforce some extra money so that I can do 300 queries in a transaction versus the 100 that everyone's allowed to do. It's kind of a very egalitarian system. It means that everyone plays fair on the shared resources. Some people aren't a fan of the governor limits. I personally am. I find that they make you think about what you're doing and enforce some good practices on your coding and your behavior. But we want to make sure that we stay within the limits and ensure that as we scale, we do not breach them. If we do breach them, we're going to get a limit exception, and then we're going to have a really big problem. A Salesforce limit exception is a special type of exception that we can't handle, can't manage, can't do anything with. Now, a lot of the work we're going to be doing here is to help us just check that we're not going to hit one of those. For those of you that have ever dealt with a limit exception in production, you'll recall that it is the worst thing that can happen. When a limit exception happens in production, it just means you're stopped. You can't change it, you can't fix it, you have to go away, manually go through, test it to try and replicate it, reproduce it and see what's going on, and then hope that the fix you apply works. But there's no way of you actually unblocking the problem without going back and making a change. It really is a terrible exception to have to deal with. So we want to avoid that at all costs, okay? So if we get a limit exception, we're in the worst possible scenario. And I can also tell you that they always happen at the worst time. Deployments with data loading, big weekends such as Black Friday or Cyber Monday, something like that, those will be when limit exceptions occur. They'll never occur on like a quiet Wednesday afternoon in the middle of July when you've got a bit of time to look at it or something like that. It'll be 5 p.m. Friday as you're finally pushing to go live and someone's doing the data loading, okay? So they're always high pressure situations as well. So anything we can do to avoid them up front is just going to make things better for us. Whenever you're testing, therefore, you want to make sure that you measure against the limits. Make sure you're doing some checks to ensure that you're not going to break those governor limits, you're not going to exceed them, and you're going to deal with that limit exception. Now, For Apex programming, it's a great behavior whenever you're working with a trigger to do a test with 200 records or 201 records in your unit testing, just to be safe and secure. Okay. Now, part of that testing as well, we'll be using the limits methods. Salesforce provides a limits class that allows us to take measurements on how resources are being used. You can use that to measure both, usage as you go, and also usage against a total available limit. So the limits class includes methods for you to take a snapshot measurement of how you are using the limits, as well as telling you the overall available resource for that limit. So for example, you can find out how many SOQL queries you have used, as well as how many SOQL queries you are allowed to use. This allows you to see how far you are against that limit, but also allows you to, when you are performance testing, see what changes you are making in there, okay? When we're using the limits methods, we're often not going to worry about the total resource limit, but we'll just be seeing how we scale and change going forward to then measure that against the total resource limit, okay? We do, however, have a Schrodinger's cat issue a little bit with the limits resources. So in order to work with the limits methods, you're going to end up running some code. Now, the effect this has should be, almost negligible. So it's unlikely to make a grand difference or a grand change, but you are going to be running code. So when you're storing data, you're storing that data for that measurement on the heap. So it will impact your heap size. When you are running those methods, they take time to run. So they will impact your CPU usage and all these sorts of things you need to be aware of. Literally making a measurement changes the state of the system in this case. So you just need to be consistent in your measurement process and make sure that whatever you're doing, you are doing in a consistent manner so that you can correctly identify the difference that the actual changes you want to make are making on the system, okay? The final step is order analysis. And this is one that not many people will be doing or be familiar with, and often has a very deeply mathematical underpinning where you start getting into big O notation and equations involving polynomials or exponentials and things like that. We're going to make it quite nice and simple here. By order analysis, what we mean is we're going to extrapolate how our solution is going to scale under load. So what we're going to do is we're going to just see how our solution uses resources when it's working with 1 record, and then when it's working with 5 records, and then 100 records, and then 1,000 records, and so on and so forth, so we can see how things change over time. So we're going to take all of these different data points, and they're going to allow us to go into detail and see how we scale. We're going to be able to draw a graph with a trend line, and we're going to be able to use that to see how our system works over time. Now, ideally, we want our resource usage to remain flat. So it doesn't matter whether we've got 1,000 records or 1 record, we're only going to be doing the 1 query, for example. However, the next best option is for it to be linear. So as you add more records, you use some more resources. So for example, in a loop, every time we run through the loop, we're going to be running those statements more and more. But as long as we're only running them for every new record, we scale linearly. It's when we get into other types of scaling, polynomial, exponential, and so on and so forth, that we have to worry about how this impacts our system, okay? Now, we're not going to go into too much detail here on this because I don't want to veer off into sort of undergraduate mathematics and how we set up. But what we need to figure out effectively is at what point do we break the system? For the governor limit we have, given the data we have and the extrapolation we can make, at what point does our system break? And how do we use that to understand where we need to make improvements? So this is going to allow us to decide on that action. So this is the detail part. Order analysis is really that decision-making part of the process within that OODA loop. We have observations where we've gathered the data. We're now orienting, doing our order analysis that's then going to feed into that decision-making piece and tell us if we need to act. So here's an example of some very simplistic order analysis I did. I have a bit of code that I was running, and that code I've run multiple times at multiple numbers of records. So first of all, run your tests multiple times to make sure you get decent numbers. You want to have good data here. Okay, you can't just run it once because you don't know. It could just be slow for a release window, or someone deploying a large volume of stuff to the org at the same time. Okay. So what you do is you run the test multiple times, retrieve an average of those results, and then scale them as you go. So you can see that I've run it here with 5, 10, 50, 100, 1,000, and so on and so forth. Lots and lots of different sets of records to allow me to scale. Now, as I've done that, there's more and more resources being used. And so the blue dots here represent the amount of, represent my actual data points. And then what I've done is I've just connected them using our dashed lines to see exactly how this works. But if I took more measurements and used a trend line, you can see here it would follow the gold line, which is our trend line. Now, the problem we have here is that as I double the number of resources, the number of records, I more than double the used resources. Okay. So for example, we can see that the spot here for 100 records is well below 1,000 milliseconds on average, whereas our spot for 200 records would in fact be above that. Okay, and so that's not scaling linearly, and so we need to be very, very aware of that. So one of the things to do is make sure as you are recording these bits of data, to plot them, do some analysis to see where things start to break. Okay, and from this, we can then use a series of tools in Excel or other analytics tools to get out what the trend line should be, what we think the equation is, and we can work with that to get our data. Okay. So now that we've taken our measurements, so we've observed what's going on, we've oriented around it by doing some analysis, we've decided to make some change or not, what changes could they be? So let's have a look at some of the code choices we can make and the implications they have on performance. So to start off here, I want to be very clear that everything I'm about to tell you is true, but it doesn't necessarily mean you should implement it. Everything within our system is connected. You can't use one governor resource less without impacting another governor resource more. Okay, everything's interconnected here. As you lower down one, you'll increase another. So it's basically a big balancing act. So as you're going and working through this, be aware of this balancing act, be aware of how things are interconnected, and make sure that as you make your decisions, you keep that in mind and don't just blindly sit there and think, I'm going to do this now to improve this area. So we're going to look at loops and how we can make our loops faster. We're going to look at the heap size and how we can improve that to ensure that we don't meet that governor limit. We're going to look at SOQL queries and how we can improve our SOQL performance. And finally, we're going to look at using the platform cache and how that can help us in overall improvements within our system. So let's start by talking about loops. I have basically grouped together loops into three rough types. The first type we have is what I'm going to call the inline SOQL for loop. And so here we can see that we have just a simple test method. This is how I run my performance tests very simply. This is a very simplistic example, but it works for us. And what you can see is I've got a bit of code where I am running a SOQL query, selecting the name from the account, and I'm doing that inline. So we have this nice syntax that we have where we can do for account ac in and our result from our SOQL query. So this is one type of loop we have. It's very easy to work with, very nice and quick, bit of syntactical sugar, and something that I think most developers do most of the time. We've got our batched for loop, and this is one of the ones that is really advocated by all of the Salesforce training. And what this does is we switch our loop from before and split it into two loops, effectively a nested loop. And in the outer loop, instead of having just a single account record we're going to work with from our query, we use a list of accounts. And what Salesforce will do for us, to be very helpful, is to batch that into a list of 200 records at a time. So if we have 1,000 records returned by our query, it will return 5 lists of size 200, one list at a time. And then in our inner loop here, we will loop through those records 200 at a time. So that set ACS, ACCS in our second for loop will have size 200. So this is a particular type of for loop that's only really available in Apex and is tuned for it. It will have some benefits, it'll have some downsides, as we'll see in a minute. but it's another way of writing our for loops. The third way is to use what I call an iterator. And this is the standard for loop that if you've worked with any other programming language, you're bound to have seen. You define a counter integer, which is typically called I or J or K or count, and you set I equal to 0. You set a limit for it, so a max here, and you say, well, I is less than that max, increment I, and then you retrieve things off of a predefined list, okay? Now for this one, we have to have our list predetermined in memory, and we'll discuss that and the impact that has in a second. But this is the most standard for loop if you're working on another platform, okay? So we have 3 different types of loop here. None of them are correct or incorrect. They are just 3 different ways of writing the same code to do the same thing, okay? But they all have different performance implications. If we measure our CPU time over 500 records, we can see that our inline SOQL query retrieves and runs all that in 218 milliseconds, so it's pretty quick. Our batched for loop is more than double that in 569 milliseconds, and our iterator version is all the way down at 64. So obviously a smaller number here is better because this is how long it is taking to run. Now, for our end user, they will also perceive this, remember. If we hit a button, it goes up to the server and our Apex code takes this amount of time to run before it returns a response. Our end user is sat waiting for that response, okay? So the difference between the best and the worst case here, excuse me, is half a second. Now, half a second is long enough that a user may notice once we include into this sending data backwards and forwards across the wire and any other processing we have. So in general, using the iterator method here will be quicker for us. It will run much faster and is slightly more performant in terms of CPU time. Does that mean we should always use it, however? Well, yes and no. As I mentioned to you before, everything's connected and this is a bit of a balancing act. So what happens to our heap size? Well, if we measure the heap size for these different versions, you can see here that both the inline SOQL and the batch for loop tend to have pretty much the same heap size going on, but our iterator is masses bigger. Okay, we're talking about roughly 20 odd times bigger. So this is a grand difference in scale. Now, one of the questions we want to ask here is, does it matter? So in the previous slide, we saw the CPU time, which is something that our users will perceive. In this instance, we're seeing the heap size. If you gave 2 end users 2 pieces of code that were running, doing the same thing, but one was using more heap size than the other, and they took exactly the same time, the user won't notice or perceive that. Heap size is one of those background things that we care about as developers. Okay. It's also important to notice here that this is 0.25 megabytes. Okay, so it's about 4% of our limit in a synchronous context. So not the end of the world here as well for the data we're holding, and we'll look at how we might be able to manage that going forward. The reason I show this slide, though, and really want to dive into it, is to reiterate everything is connected. Okay, we can't make a change in one to improve one without hampering the other. Okay, there's no free lunch here. On the flip side, different resources have different uses, and one may actually be okay to use up quite a bit that the other might not be. So here again, for an end user, the heap size, they don't care about, but they will notice the difference in half a second. This can be extremely important here when we're doing things at scale in sort of batch Apex and things like that, where we have a much higher heap size limit as it is running asynchronously, but we need things to run more performantly if we are processing millions and millions of records and want it to be done in a set time period. Okay. So let's move on to the heap size more generally. So the heap size is just everything that our system has in memory. It is its short-term memory. One of the best ways we can improve our usage of the heap size is to have better scoping. So smaller methods have better scoping. So in general, you want to follow good OO coding practices. Small, discrete methods and only class scope items that need to be in the class scope. Okay, don't have lots of member variables and properties that don't need to be in that unless you truly need them. Okay, by doing this, the Salesforce garbage handler, which is actually built on the JVM, will work brilliantly, be very memory efficient, it'll scoop up everything it needs to, and you shouldn't have any heap size issues. You can actually manually remove items by setting them to null, though, okay? So if we were doing our previous loop and we had that big utilization, if I then set that list to null at the end, it would clear all that memory away from me as far as it's concerned, and it would reduce our heap size usage. So very useful for large sets of records, like the instance we've got there where we want to pull them in memory. Also very good for blob data. So if you are working with data from a file or an image, something like that, where it's blob data that you're putting into a content document or has a file upload, something like that, you're going to end up with a large set of heap size data usage. So it's a good practice to be making sure that you set that to null at the end once you finish saving it, and then it will reduce your memory footprint. Okay. Let's move on to SOQL now, which is also going to impact our heap size. So if the heap size is the amount of things we have in memory, we can impact that by improving our SOQL. So one of the things we can do is, first of all, make things faster by running fewer queries. Every time we run a query against the database, the force.com query optimizer has to go away, interrogate our SOQL query, rewrite that as SQL against the underlying database, make that query, retrieve those records, filter them down, run sharing rules, yada, 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 and return them to us. Smaller number of queries means this will run faster. So if you can get data from a parent and a child in one query, do so. Don't run 3 or 4 queries if one will do. As I say, every time you can avoid a trip to the database, it will be quicker. I think I remember reading many, many years ago that Salesforce will always try and run a SOQL query in less than 300 milliseconds. Now, that is incredibly fast in general, given everything that's going on, but make 3 queries, you've added a second potentially on there. Okay, so be very aware of that. Now, that's not an official statement. I've not been able to find that document since, but if we were to take that as a rough guide, it'd still be a good one for us to be aware of. If you're using the same thing multiple times, cache those results. Store them somewhere where you can reuse them. Improve your selectivity to make sure you're returning a smaller amount of data, as this will make it A, quicker for you to process, but B, also now help with your heap size, as we know. So the way to do that is to use an index filter. Excuse me, this will make both your query faster, but also mean that you can really zero in on just the data you want. And so those are things like IDs, names, external IDs, things like that. You also want to implement a strict sharing model. Now, we touched upon this briefly when we were talking about the scaling portion here, but if you don't have strict sharing in place, when you run queries, there are a bigger set of records for the system to have to go through. If you implement a very good sharing model where things are locked down for those that only need to see them, then it'll make it much easier for the queries to run. They'll be much faster. And even for things like declarative pieces, such as reports and dashboards, they'll be quicker as well, as they're all using SOQL in the background. And again, use a limit. If you don't have any way of doing an index query, at least have a limit on there. Limit it to 10 records, 50 records, 100 records, whatever. Just add some sort of limit on there. The final thing we're going to talk about is the platform cache. This is a, excuse me, a fairly new addition to the platform within the past few years. And what it is a temporary data store for frequently accessed but seldom written data. Something that you might be trying to retrieve multiple times within a user session, but will only get updated maybe once a day or every few hours. There are 2 types of platform cache you can work with. There are org-wide, which means that it's shared across the entire Salesforce organization, and session-based, which means that it is only there for that user session. Once that user session ends, it disappears. You should make sure you're using the right one for the right purpose. When should you use this? Well, obviously, excuse me, when you have data that you read very often, but you write to infrequently. So if you have, for example, current VAT rates or tax rates, those change very, very rarely. Or if you have exchange rates, those change very, very rarely for most accounting purposes, but you want to read them very often when you're working through your process, okay? Also really good if you have an asynchronous jump in your system. So I was working on a system recently where we had a synchronization to a third-party solution that would then update Salesforce. So a customer in a community would make a change to their data, that would get sent via a web service call out to this third-party system. It would process that update and synchronize a record back to Salesforce for the customer to use. Now that took a bit of time, so rather than wait for that and the customer not be able to interact or not be able to see if there was, not be able to use the rest of the community, what we did is we manually put something on the session cache that would then overwrite some values so that whilst the background processing was happening, we could fake it until that background process finished. As I mentioned, exchange rates here are a very good example of data that you would retrieve maybe every few hours, stick into a cache to use, but you might be using very, very regularly when pricing something. So the final section of this talk is on architecture choices and performance. And there are three key architectural areas or ideas I want to talk about here. The first is clicks versus code, that never-ending debate, and what that decision will do for the performance of your application. The second is whether to be synchronous or asynchronous in your behavior. And the third is to ensure that you have things going on in an ongoing review. So with clicks versus code, it should actually be clicks or code, never one or the other, but both together. They should work in tandem to get the most successful and most optimal result. You need to learn how to use them effectively for them to scale correctly. So part of that is understanding where the boundary is and how to communicate across that. What are we going to say our declarative tools are doing? What are we going to say our programmatic tools are doing? How does that line up and how does that work so we can enforce that? You also need to understand the migration path from one to the other. When is it that we want to move from something like Process Builder or Flow into code and why? I've worked in many solutions where I've seen very large, complex flows with hundreds of different points on them, or 10 or 15 process builders that are very difficult to manage and overlapped. That's a good idea to move to code to just simplify it to having a single location that can run in a defined order. But what does that look like from an actual migration path? How do you do that? How do you make that decision? How do you test it? Understand how to do that, where that boundary exists, and stick to it, as that will just make you very effective, and then you can test against it. The key thing here is to just keep on following the best practices. Salesforce have communicated them, they're there for a reason, they're well tried and tested, and they'll ensure that you have the best success. We want admins and developers or clicks and coders to be able to work together in the best way possible for the best scale, and the best scale will come from using both together. So make sure that you try to do so. The next big thing to think about is whether you want to have something be synchronous or asynchronous. Key question here is, does this need to be done now? When you're taking a specific action, think about whether or not that action needs to be immediate. Then need to think about, do all of these pieces or all of these updates need to happen now? Some of them might do, some of them might not. How can you separate that out and what are the implications of that occurring? What's the user's perception of those occurring? What else hangs off of this event occurring is a big question here. When we look at a process end to end, often in larger deployments, we have multiple different things hanging on together where one event will trigger another event, will trigger another event. How does that all hang together and how can we separate that out into discrete blocks that we can work with? With that, you should then understand your options for the different asynchronous pieces of processing you can do on the platform and how to work with them. Future methods. Scheduled jobs for something you want to run at a particular time. Batch jobs for processing lots of records. Queuable for working through a queue of items end to end and being able to retry if you need to. Web services, both inbound to Salesforce and outbound from Salesforce. Working in both directions can really help you simplify things and make it a lot easier to coordinate actions going on. And then finally, platform events, which not really that new now, but are something that a lot of people still haven't utilized fully within the system. They'll allow you to separate things out, build far more event-driven architectures that allow you to have discrete units of work that can make it very easy to coordinate in near real time. And the big piece here is to just remember that everything's an ongoing review. Always keep measuring, always keep tweaking. It's a famous thing that carpenters say, where you should measure twice and cut once. We should also be doing that. It should be part of your release cadence to add any improvements for the next release. Testing as you're going, make sure they're acceptable, make sure that when you release, it meets your criteria. But if there are changes that you need to deal with going forward, be the one to find it out yourself, and then you can start working on it before a customer finds it. Should be remembered that today's solution is tomorrow's problem. I have built many systems that worked wonderfully at the time, and then 3 or 4 years later, there's been some change in business requirements, a few things have got tagged on, and it happens. Everyone ends up building Homer Simpson's car where they just bolted on so many things, and it looks a bit like a Frankenstein's monster, and it doesn't work as you want it to and doesn't scale properly. So you need to be able to change and adapt your system. Remember that perfect is the enemy of the good. You're not going to come up with the system that will forever last. What you need to do is have a system that's scalable enough for what you know now, scalable enough for some of the things you think are likely to happen, but can be adapted and changed going forward. And then the final thing is to keep a good eye on release notes. Salesforce will announce a load of new features every 4 months. They're probably going to help you change things, do things in a different way. For example, platform events, when they came out, they opened up an entire new way of thinking about working with applications. New features are going to be able to help you scale and grow, so don't be afraid of starting back over. If you need to delete something and start again, that's perfectly fine. It's actually a very healthy process to be going through. So make sure you're comfortable and can do that going forward. Okay, rework something for the better when it's possible. So the final thought I have here is just a quote from Donald Knuth. Premature optimization is the root of all evil is the very famous part of this quote, but I think it's really important to share all of it. We are going to be looking for that 3%. As long as we're comfortable that our users are getting the performance they should be and that they perceive should be okay, we're going to be great. We don't want to sit there and look at all of the many small efficiencies we can get that are going to just take up just things that we don't need to worry about. Salesforce does that for us. And if you think about that diagram I had at the start, Salesforce is doing a lot of legwork for us across the network, across routing and handling and rendering and all these things. We don't need to worry about all that. What we need to focus on, excuse me, is the critical 3% where we can make a big difference in that area. I have a big section on this in my book. If you're interested, you can go and find out more there. There's also some stuff I've done at previous London's Callings and other blogs where you can find out more, but it's a really interesting topic. I hope you found it useful. And of course, we can't end a programming talk without an obligatory XKCD. So thank you very much. I hope you've enjoyed this. I hope it's taught you something that you can go and learn now and enjoy the rest of your London's Calling. Thank you.